My name, as Arthur said, is Daphne Preston-Kendal. I'm the chair of Working Group 2 for the R7RS Large revision of the scheme specification. Sorry, I'm good. Okay, you can hear me. Super. Yes, I'm chair of the working group for the scheme specification R7RS Large, and I'm here to talk about that, how that's going today. I'm going to give a fairly high-level overview of recent work. If there's any details that people are interested in, I can talk about that in the questions at the end. I have been told that there will be no oral Q&A because this is a remote presentation. You can ask me over IRC or on the Twitch chat, and I will be happy to answer questions there. So I assume I don't need to go too much into the history of Scheme for a Lisp conference invented by Guy Steele and Jerry Sussman in 1975, and specified subsequently up to 1998 R5RS by unanimous consensus. That meant everyone on the committee had to agree in order for something to actually make it into the spec. R6RS was designed by majority vote, on the other hand. It was not quite as widely adopted as previous specifications had been and frequently criticized for various reasons. A number of people felt it was too large, not in quote-unquote the spirit of Scheme. So in 2009, the Scheme Steering Committee resolved to split the language into two parts for the next version. R7RS Small was completed in 2013. It's intended for education, research, and embedded use, mainly. And it takes as a basis a significantly more conservative revision of the R5RS than R6RS was. And it has been very successful in the sense that it's been adopted in some form by all currently maintained implementations of R5RS. What R7RS Small gave you, compared to R5RS, the biggest headline feature was a portable library system, which is interoperable with the system in R6RS. It's not the same, but an implementation can easily support both. Exception handling and raising using the exact same API as in the R6RS. Record type definitions, so you can finally, in the portable scheme, in a portable scheme language, create your own data types, which was not in R5RS. We acknowledge that Unicode exists now, so we have a sort of clean split between binary I/O, textual I/O, and that's also works in roughly the same way as it was in R6RS. And for actual language features, we also have parameters, which are kind of variable-like boxes, which have dynamic instead of lexical scope. R7RS Large, compared to the small language, which has a very limited scope and is aimed at potentially very limited environments, is aimed at the quote-unquote practical needs of mainstream software development. So we started this in 2014, initially under the chairmanship of John Cowan. 2022, we resolved to split it into two or possibly three parts. The first, which I'm mainly going to focus on today, is called the foundations. This is an extension of these core language semantics of the small language in order to make it more suitable for the purposes of a large practical programming language. And hopefully this will be done by the end of next year. We also have the batteries, which will provide useful standard libraries with a scope that means we hope not to standardize anything that people will think is no longer relevant in a few years, for example. Hopefully that'll be finished soon after the foundations. And then we have the environments, which will provide operating system interfaces of some variety. We have no specific target completion date for that yet, but I'll talk about that later. 2022, we also resolved that R7RS Large would be R6RS compatible. My goal as chair is not only to reunite the languages, but also to create a platform around which we can reunite the community. So we recognize that some implementations are only going to implement small. That's fine, that's what it's there for. But we hope those who are doing quote unquote real programming in Scheme can all see in R7RS something that they like. The most recent work has been focused on the macro system. We did a lot of work on that in the last few years. So I'll start by just talking about where we kind of left off, what the R5RS provided in terms of macros. So this is the syntax rule system. Here I'm defining just a simple example macro to swap the values of two variables. I've called it swap bang. We use the syntactical system and we say the form of the macro, not only the arguments has the form something and then in some kind of subform X, some kind of subform Y. And these X and Y will automatically be substituted into this bit, which is the expansion of the macro, what it will be replaced with. So with this X and this Y. Hygiene is handled automatically. So most obviously this temp variable that we introduce, if X or Y is already called temp, for example, that won't cause a problem. It will be considered to have a different name. And also if the names let and set bang are for some reason rebound to something else at the point where the swap bang macro is used, or they're not available for some reason, that doesn't matter. These names will always refer to what they were, what the macro author intended, what they were at the place that the macro was defined, not the place where it's used. So it's a very nice, simple system for simple macros, but although it is Turing complete because you can do recursive expansion, it becomes a Turing carpet very quickly for more complicated macros. There's no possibility to compile time with scheme evaluation, and there's no way to choose to break hygiene. But these are the compromises that R7RS had to make because at the time, as I mentioned, everyone had to agree. It had to be a unanimous consensus, and nobody could agree on anything more specific than this system that would allow you to do more. R6RS extended the system to overcome these limitations and define something called syntax case. So here my transformer procedure, this is the macro that does exactly the same but using the other system. Here my transformer for the macro is just an ordinary procedure. It gets an argument, syntax, which represents the entire form of the macro use. I use the syntax case special form to destructure that. There's exactly the same pattern here. The difference is that I can do scheme evaluation in the actual body of this definition. In order to tell scheme that this is the expansion of the macro, I use this sharp quote thing, which just means do exactly the same thing that you do when this is in a syntax rules macro. So it will substitute the X and the Y. It will take care of hygiene for the temp and let and set bang identifiers that we've referenced here. I can also, because I'm able to do compile time evaluation, I can also choose to break hygiene. I can actually do this in a way that allows hygienic macros, fully hygienic macros, and unhygienic macros to compose with one another. This is a key advantage of the syntax case system over competing procedural macros in scheme. So here I say datum to, I want an identifier for this escape procedure. I want it to be called return always. But I want it to be in the lexical context, the same lexical context that the actual name of the macro at the site that it was used. So I have here, I get that from here in the pattern match, and I put it here. And here for this particular macro, this would mean that if someone were using this early escape macro within the definition of a hygienic macro, the return would be available to them as the macro author, and not accidentally also leak out to the person who uses what they thought was otherwise a hygienic macro. We also have identifier macros. So these correspond to symbol macros in Common Lisp. Here I have an example which just optimizes the concatenate procedure in one particular case. So I'm flattening out a list, and this recognizes, okay, when the argument is a map procedure, then actually I know a faster way to do that. I'll just delegate to the append map procedure, which does the concatenation and the mapping in one go, rather than consing up an intermediate list. And in other cases, it will just work like the regular concatenate procedure, including in the case that I use it as a first-class procedure, because here I say, if the procedure if the macro name just appears on its own, I check is it an identifier on its own, then I just return instead, replace this with the name of the concatenate procedure, and that will continue to work as a first-class procedure. The R6RS syntax case system has been criticized, and we're trying to address those criticisms where we can in R7RS. The main criticism we're trying to address is that in R6RS, the syntax case system is the only possible way to do any macro parsing. any way to find out what the input to a macro was. And this is a high-level syntactic system. There's no low-level procedural equivalent. So we've provided a low-level procedural equivalent called unwrapped syntax, and as you'll see later, that actually gives us quite a bit in terms of how we can express syntax case itself. Another complaint schemas make is that identifier macros can't tell if they get an identifier as an argument. They can't tell, is that going to be a variable or is it going to be a full macro? To this, we say we can't really do an awful lot about this. We think it's more valuable to have identifier macros than to have code walking macros. Code walking macros do not compose very well with one another. And an identifier macro which doesn't behave like a variable is probably just bad style anyway. Others we can't really do much about without sacrificing, at least not without sacrificing compatibility with R6RS, which again we consider a more worthwhile goal. The idea that the syntax case is too large, that plays into other criticisms of R6RS, that it requires reader extensions. We could, in principle, get rid of those, but we think R6RS interoperability is more worth aiming for. We're also adding some new features in our R7RS Large. The first and one of the more exciting ones I find is identifier properties. So these are kind of like classical Lisp symbol properties, but unlike symbol properties which exist at runtime and are global, they respect lexical scoping and the library system. So they are attached to the binding at expand time rather than to the symbol itself at runtime. That means the property is imported when the corresponding library where that identifier is defined where it's exported from, and they have full lexical shadowing behavior. So if I redefine a property locally, that will have only local effect. If the entire variable is shadowed, then all of the properties will become invisible for the extent of that shadowing, because we assume that the properties have more to do with the binding for that variable, for that identifier, than they do with the actual just name of it or whatever. They are available only at expand time, but also by extension, if you need them at runtime for the REPL, whatever, you can get at them through eval. And the REPL is obviously already has eval, is already doing that for you. So an obvious use case for this is just to attach debug information, documentation information, useful to programmers while they're developing, but it also allows macros to communicate with one another. So I can have one macro which sets an identifier property, and another macro which uses that information, so that these two, maybe nested inside each other macros, can exchange information, and that makes the macro system more powerful. I can also establish a context-specific usage for identifiers. So, for example, the X and Y we had earlier, those are called pattern variables. That's a specific usage of an identifier. And because I now have identifier properties and unwrapped syntax, I can actually express syntax case in terms of lower-level primitives portably for the first time. And I hope there will be a portable implementation of the pattern matcher in terms of these lower-level primitives included with the report. But I can also do things perhaps more useful in runtime code. For example, I can have an extensible pattern matcher where I can have the definition of a particular type of pattern attached to a particular binding as a property. We currently have a working test version of that, and it's very exciting. Another new thing we have is called syntax parameters. These are kind of correspond an expand time equivalent to parameters that I mentioned earlier, and allow me to kind of appear to break hygiene within a syntax rules macro without really doing it. So the way that it works is that if I were to use this version of with return, I don't only export with return itself, I also export the syntax parameter called which is actually called return. That means we have a shared binding between the macro author and the macro user, and the macro definition can actually just say, adjust that binding that we already have in common. Instead of creating a new one, just change what it means to point to this return procedure that I'm going to create. And when it's not used inside of a with return, then it returns an expand time error. So this is a nice alternative to actually unhygienic macros for the specific case when the ejected identifier always has the same name. You can't do things like automatic field names, automatic accessor names for a class in an object system with this, but you can do that with the other system that I mentioned before. But this is an alternative solution for cases like that. Looking ahead slightly to what we're going to be working on, what we're currently working on, and what we're going to be working on in the future. So the next stage has to do with kind of what different types of values we provide in the base foundations language. One of these is two types to do with storage management and garbage collection. We have already agreed to provide ephemerons. These are the right thing among various weak pair, weak box primitives. As far as we know, all of the existing other weak pair semantics can be implemented in terms of ephemerons, but not the other way around. We also have guardians. This is a quasi-deterministic finalization mechanism. It's quasi-deterministic because I can't control when the garbage collector itself runs, but I can say when I want the actual finalization code to run. So the garbage collector, instead of just running the finalizer directly, will queue it up, and when you're ready to finalize the object, you say, okay, give me all the objects that are ready for finalization, and I'll deal with those with cleaning those up. A current challenge we have is providing a primitive to allow pointer-based hashing for data structures, hash-based data structures that the user might like to write. So pointer comparison is used fairly often in Scheme, but pointer-based hashing is a problem in a moving garbage collector or a compacting garbage collector, because you can't use the actual pointer as a hash value. It might change when the heap is compacted. So there's a couple of approaches here. We can ask implementations to just find some way to deal with it. There's a couple options, like they use a hidden hash table behind the scenes that they have to rearrange themselves, or they just lock any object in place if they know it's been hashed before. Or we move that burden to the user and say, okay, if your hash-based data structure uses an EQ-based hash function, you need to be aware that hash value might change, and we'll provide a way for you to know when that's happened, but you need to be aware that rehashing is something you might need to do in that case. As we look further on, past the immediate future of work we're doing now and very soon, we will be adopting something like the R7RS condition system and changing a lot of the undefined behavior in the small language, which was mainly there to allow smaller implementations targeting very limited environments. Those will be changed wherever possible, wherever realistic, to require an exception to be signaled, or at least something sensible to happen. We are going to ban nasal demon type situations for most erroneous uses of procedures and such. Our revision of the condition system may involve adding restarts like in Common Lisp. The R7RS condition system is very nicely extensible, but it did not include restarts itself, but we could add them. I would like to see this. I'm not sure that may come, that may not. I can say with some certainty we will have delimited control operators, not replacing call CC, probably either complementing or extending it. So we may add something similar to a shift reset operator in addition to call CC, although probably with multi-prompt support. Or we may adopt a solution similar to Rackets, whereby call CC becomes part of a collection of delimited control operators, which you can use in various different ways. And we may also have some solution for threading. I think this will be very useful, but it is hard to require this on some platforms. So if we're talking about what mainstream software development looks like today, I think that has to include, for example, the web platform, running Scheme programs in a browser. And in that environment, multi-threading at the moment is not an easy proposition. So actually requiring implementation support that is would be quite tricky. That's a countervailing consideration. So that's the foundations sort of as a whole, what's coming up, very high level overview. Just want to talk about some of the challenges we face. The enthusiasm of users for a larger core portable scheme language is very high indeed. From users I've talked to, a lot of scheme users are would very much want to see a scheme language where they can more easily write libraries, for example, that will work in multiple scheme implementations and have a more robust condition handling system than they could do with the fairly limited one in small language, for example. On the other hand, implementer enthusiasm is no, I don't want to say they're not enthusiastic. I've had some very productive conversations with implementers, but we have to consider that, I mean, everyone who is involved in the scheme at the moment is doing this as part of a volunteer effort. This is not like the standardization of Common Lisp, where there were commercial entities involved. All current scheme implementations are maintained by volunteers. All of us working on the specification are volunteers. So we have to be kind of realistic in terms of in terms of the overall scope of the project. So just before I finish, just a few quick words on the batteries. The batteries will provide data structures and algorithmic primitives that you kind of expect to see in a functional language in the current year. They will be portable in terms of the foundations. We will provide sample implementation that will work in any conformant implementation of the foundations. And also we encourage people to come up with their own solutions and even their own complete alternative preludes for scheme. The batteries are conservative in scope by design. This is, as I mentioned earlier, we don't want to standardize something that will turn out later to have been a mistake. And we also want to leave space for innovation and not to kind of forestall things that other people might want to do with the language, but then they would have to kind of break with whatever the de facto standard is that the scheme provides itself. So we're talking more things like the battery will contain a hash table library, but it won't contain an HTTP server, HTTP client, or ID3 tag parser. That is not what we're looking for with the batteries. And a few last words on the environments. The scope, and again, an overall approach that we're going to take here is still very unclear. It is potentially a very big project. I'm aware of this. I would like to avoid it getting too out of control. But there are a few must-haves, I think, in my own personal view, like TCP networking, hopefully with simple TLS, because practical networking today requires that. Hopefully some kind of cross-platform fast name and file system stuff, and some limited kinds of process control. The problem here is quite simply working out what to standardize, whether we should go for a high-level approach or a low-level approach. We're looking at what WebAssembly is doing with the WASI architecture as kind of a modern approach to a secure operating system interface that works across different platforms. We'll see how things work out there. I suspect these will end up being smaller rather than larger in terms of what you can actually do in a portable way. But the scheme community has ways in which we can continue to allow the language to evolve outside of the R7RS process. So if people want to want to standardize something, kind of like Bordeaux threads and other de facto standards in Common Lisp, we can the scheme community can do that. We're not setting an absolute limit for the future. So it is now time for questions. As I said, these will take place only in IRC or in the Twitch chat. I will switch over in a moment to that in order to answer your questions. You can look at the slides for this presentation at the link at the bottom of the slide, and you can also email me any of your questions if any occur to you later at my email address just down there as well. So thank you very much. I know it's been kind of a very high-level overview, as I said, and I hope I've piqued your interest for at least some of the features that we're going to have in R7RS Large. Thank you very much.